So today we will be discussing about the basic fundamental of gear simulation and analysis with an related software, that is ansys. The gear is I have made this gear previously with all the design parameters, dependability characteristics. I have designed this gear as per my requirement. So let me show you that gear. So this is the gear. All the parameters are set. Teeth are well defined on a circumferential periphery of that gear. The holes are provided for the reduction ratio or for weight reduction, and this inner side is hub of a gear. So first we are importing. Our first process is to import this gear into ansys modular, and there I can tell you how to analyze this gear on different aspects. There are different types of method to analyze or apply force on this, so that we can get maximum or related deformation with respect to this material which we are assigning. So here we start with our ansys workbench. So this is the basic layout. These are the tools which we are going to use in our design. There are different types of tools. All engineering tools are incorporated in this software, but we are doing only static structural. These are the interface. So static structural. I'm not going to tell you all the procedure. I'm only going to tell you how the basic fundamental in ansys works to analyze different components, or basic algorithm which he used, basic concept which ansys software applies on any geometry, so that any component will be analyzed for further processing or post processing. So this is design modular for static structural. Here we have to import that gear and apply the different structural condition to that gear, so that in further processing it will be analyzed by the software itself, which components we are assigning and which material value should we take and what unit we want that value. Writing will take further time. So our geometry is set, and engineering material by default it is selecting static structural material, which is having a modulus of elasticity of 2 into 10 to the power 5 MPa, and let it be. And this is the main part. From here the main solution and post processing will be started. In model we are creating different mesh modeling on the gear. So our geometry is completely imported in static structure multiphysics mechanical. It is a design modular interface. Here we have to create meshing. Meshing is a discretization process where the software dividing this gear into small elements. So in this the total element will be divided into small chunks, and in every element or cell we have to call it as shell. So this is the shell portion. If we see in depth, some are triangular, some are rectangular shells. So it It is basically in back-end calculation, it is generally applying a Moore circle theory or complex stresses and strain. Some of the triangular or granular structure are subjected to biaxial stress system or some of uniaxial stress system. Mainly the outer portion is generally subjected to biaxial and generalized condition stress portion, and internally the gems or shells are created. It is subjecting or experiencing the pure shear concentration forces. So by it is calculating for single element in a matrix form and combining them, so that our deformation value or stress value should be evaluated for whole gear. It is not calculating for all, it is calculating average of all the elements. So first we have to apply boundary condition here. This is the geometry created, mesh generation are created. In static structural, we have to load this component. I am not going to load fix this. I am applying displacement theory. I am giving a displacement 0 in x, y and z direction, so that it cannot move in 3 axes, and after applying my forces I will be getting my deformation value or stress value. There is another method to analyze this gear. You can fix this hub and apply a force on gear tooth, all gear tooth, and see the deformation value. Otherwise you can fix the outer periphery or circumferential portion of the gear and apply a moment in hub portion. So you will get your gear will be analyzed for safer condition only in both the cases. So this is the two method where you can analyze the gear for any industrial purposes, and you will get an exact value for it. So here I have fixed the inner portion, that is inner hub portion of a gear, and I have applied forces on some teeth. Make sure when you apply a force, it is in x direction. I have applied, depending on these axes you should apply a force. So my requirement is of, so while I am designing the gear, I am designing for 400 Newton force. It can be applicable for absorbing 4 Newton force, 4000 Newton force. So count the gear for which you have applied a gear. There is 4 teeth on which I am applying a 4000 Newton force, and after evaluation note the deformation value, and divide it by 8, because number of teeth are 8. So same. So this is the basic analysis which I have created. The deformation value is maximum 1.9848 e raised 10 raised to power minus 5 maximum deformation, and you are seeing that this hub portion is safe. So the factor of safety of this gear is very high, and we can reduce the thickness of his inner portion. So maximum optimization should be takes place. Material saving capability will be there in all engineering aspects. So note this value 1.98 to 10 to the power minus 5 divided by 8. So we are getting the value. So in previously I have applied load on 8 teeth, that is 1000 Newton. Dividing the deformation value divided by 8, we are getting 2.47 into 10 to the power minus 6. And now I have applied force on only one teeth, and now I am getting the deformation value 8.48 into 10 to the power minus 6. The values of basic value of unit digit we have found to be different, but the ratio in which the proportion they are changing, that is 10 raised to power minus 6, and here 10 raised to power minus 6 value, it is approximately to be same by saying that proportional rate 10 to the power minus 6. So this tells us that our factor of safety of gear is very high and it need to be optimized. If you don't optimize, then it is okay, and the gear can take more than 1000 or more than 2000. So because of that, deformation value is very less. So this is the basic analysis criteria for gear. In a further video, I have to tell you about that when gear is modeled or analyzed in CATIA of software, where we can calculate forces and deformation or stress calculation at every point. Suppose this is the mesh and it is creating a nodal point here. This is the mesh and is creating a nodal point here. So this, at this particular point, we are getting the exact value for deformation and stress in CATIA software.